What's up, math people? We were talking about the system of linear inequalities. And to review just some of the things that we've gone over, the easiest way to find the solution to a system of inequalities is to graph it. While you can find the intersection point by substitution or elimination, you will need to graph it to be able to get a real understanding of which answers are valid solutions. So for instance, if we were graphing the equation y is less than or equal to 2x minus 3, the 2 is the slope of that line, so it's going to go up 2 and over 1, and the negative 3 is where it's going to cross the y-axis. So we can graph that line. As you notice, it's equal to, so it's a solid line, and it is less than, so we are going to shade under the line. If we were picking a point that would work for this, we could pick any value of x, right? And for instance, I'm going to pick 1. So when x is 1, we plug in a 1, 2 minus 3 would be negative 1, right? And as you can see, when x is 1, the first point that would be a solution would be negative 1. So that's how I could pick a point. 1, negative 2 would also work. 1, negative 3 would work. 1, negative infinity would work. All right, and then to get the actual solution to a system, we are going to use two different equations here, right? And to find the solution, we would solve, right, for that point right there. But to get all of the correct solutions, we would need to graph both of them so we can see the shaded area of the graph, right? And so this blue line right here crosses at 2.5 with a slope of negative 1.25, and the red line has a slope of 2, right? Like we just talked about. So since they're both less than, we would be shading under both of those graphs. Okay, and then to find the solution of 3 systems of inequations, right? This one you notice is greater than, and so we would shade above that, giving us the shaded area right there. Homework. So what is given to you right now is the inequality, and what I would like you to do is shade the region that is determined by that inequality. So remember that if the inequality is facing away from the y value, right? If the x is greater than the y, we would be shading under the line. So y is less than x, that means we're going to shade under the line. I would then like you to pick a point that works. So for instance, the line is at 1/5 x minus 4. That means it crosses the y-axis at negative 4, and it goes over 5 and up 1 as the slope. I would like you to pick a point that works for this inequality. Since it is less than, I would shade below the line, so any point below the line would work. For instance, if I went to 2 on the x column, I could go down to 4, right? Anything that is below the line would work as a solution for this. Okay, on to number 2. If we have something that is greater than, right, we're going to shade above the line, right? As long as the line has a tilt to it, right, as long as it has a slope, you should be able to determine which side is above and which side is below. In this case, above is over on this side of the line. Everything over here would be considered below. So we would be shading on this side of the line. Once again, you would want to find a point that works for that inequality. What if it is not in slope-intercept form? Well, we need to convert it into slope-intercept form. So what that basically means is I need to isolate for my y value. To do that, I'm going to move all of the numbers away from the y. In this case, I would actually start by adding 2y to both sides. If I went the other direction, it might be less steps, but I would have to flip the signs. You can go any direction you want, but I'm going to start by adding 2y to this side and 2y to that side. I then have 5x is less than or equal to 10y plus 10 plus 2y, and then I would subtract 10 from both sides. I now have 5x minus 10 is less than 2y, and my last step would be to divide by 2. So 5 over 2x minus 5 is less than or equal to y. Since the y value is since the inequality is pointing towards the y value, meaning y is greater than, I would shade above this line. I could then pick any point over here that would work for my solution. So I could pick one over here. So negative 6, 0. I don't know if that's negative 6, but negative 6, 0 would be somewhere in the solution set for this inequality. So once again, we're going to convert to slope-intercept form by isolating for our y value, and then we can determine which side of the line to shade. Moving on to your set, I want you to write this inequality. Okay, so we're going to start by writing the equation. To write an equation, we need to figure out where it crosses the y-axis and what its slope is. Then we can plug it into y equals mx plus b, where m is the slope and b is the intercept. So in this case, our intercept is at positive 7. So we are going to add 7 to our equation. Y equals mx plus 7. The slope is down 1 over 1, which would be a negative 1 over 1, or a negative slope. So y equals negative x plus 7 would be the inequality. Now I need to change it to an inequality, and in this case, it is equal to, but less than. So I would have the inequality facing the x value, or y is less than or equal to negative x plus 7 would be the correct equation for number 5. Notice that 6 has a dashed line, so you wouldn't have the equal sign on the inequality. Please write the equations for 7 and 8 as well. And on to the go section. On the go section, they basically just want you to create a scenario where this would be true. In this case, we're going up by 8, so I expect you to be able to write that equation, y equals mx plus b, in slope-intercept form. I'm not super concerned about the context. I know you guys all have creative imaginations. What they mean by that is like create a situation where that would be true, right? Claire is earning $8 of allowance per week in this scenario, right? I do want you to try and graph it. And those are the go sections. There's about 4 of those. That concludes your homework for today. If you had any questions about any specific topic, please ask them during the live discussion, at which point you should return to it right now. So please